This is a quick video to answer another very good question that came up in the comments in relation to my last video, and it related to whether or not I used an inverse assembler on the analyzer. Analyzers like this will support various software and hardware features and accessories. One of those is called an inverse assembler. For anyone that's not familiar with an inverse assembler, what they do is they take the data that's been captured from whatever device you're trying to test, and it will turn it in real time into a reverse assembled listing. So this analyzer not only has the waveform view that we've been looking at so far, it also has a list view. So this is the same data that is present on the waveform. The only difference is, of course, it's in the format of a list. What the inverse assembler allows you to do is essentially give labels to all the known addresses. So for example, if it's a port value, then whenever that port value is accessed with an in or out instruction, then the reverse assembler will put that into the list view, telling you that you've accessed port A, port B, or whatever name you've given to it. Now, they're very useful for examining small sections of code. They'll give you a snapshot of the bit of code that you've captured, and then you can scroll through it almost like it's a listing. So it gives you a result that's fairly similar to something like this. The main disadvantage with them is they are just a snapshot. So unlike this listing that I've created, which is the entire firmware in a single listing, the list that's present on the analyzer is essentially decompiling or reverse assembling the entire data that's been captured. So for example, if you're in a loop, as almost all the code in this machine is, then you'll just get repetitions of the reverse assembled code. It is quite readable. I actually find it just as easy to look at the waveform, but as I said, the main disadvantage is that you just get repetitions of blocks of code, and what I wanted to be able to properly examine the operation of this machine was a single printed listing that I could reference and see how the software worked in its entirety. So that's the reason why I tend not to use inverse assemblers for this type of work. It's because it's a kind of all or nothing thing where I need the entire listing to be able to make sense of what's going on and where the fault I'm looking for may lie. Another disadvantage with inverse assemblers is that as we go through the following videos, you'll see a lot of what we're trying to capture is what we might call off-chip. It's not any of the inputs that go directly to the microprocessor. It's maybe inputs and outputs of the PIAs or the serial chip, and of course the reverse assembler would not be able to make any sense of that because it doesn't relate to operations that are on the data bus or the address bus, which is what the inverse assembler needs in order to be able to decompile the code. So in other words, what I'm mainly interested in looking at are the input and output values from the PIA peripheral devices rather than the data and address values, which is what we've been looking at so far. So I hope that makes sense. I hope it'll make more sense as we go through the next few videos and start looking at the way that I determined how the hardware worked.